So in this video, I want to show you how to generate a lot of game objects quickly and also with varying attributes. And we're going to use an array for this. Actually, we can use anything. We can use a list. We can use an array. To be honest, we can use anything really. So let's get started. So previously, what I've done is I've created two balls from this blueprint that we've generated, this blueprint on how our ball is going to behave, and I generated two balls. Right, I create two balls of varying there, and then I loaded the balls in, updated the balls, drew the balls separately. But if you want 100 of these, again, it's annoying. You got to copy and paste and then have to do this 100 times. So what we could do is, instead of generating balls like this, we can create a list of balls. Now I'm thinking whether I should use a list or an array. I can use an array, it's fine. But you know what? I'm going to change it. So really I'm going to use a list. So as list of balls, just makes life a bit easier. I said arrays originally, but I've changed my mind. Of list. So we're going to make a list of balls. List for the balls. And in game load, we're going to generate a whole heap of balls. We're going to use a for loop. For I equals to 0 to 100, let's generate 100 balls. We're going to go balls.add new ball, and we just need to put in random parameters for these four things. So now we need a random number generator. Have I got one up here? Nope. So we'll create a random number generator, dim rand as random equals new random. And then we need to generate four things: X, Y, size, and V speed. Right? So we'll generate four things. We'll go dim X as single equals to rand.next double times, what's a max speed? What's a max display? We don't want it to spawn. We don't want it to spawn. Actually, max display size dot width. So we don't want it to spawn outside of the screen. So we generate a number between 0 and whatever the outside of the screen is. Do the same with this one, except we're going to look at the height of this of the display. For our size, what's a good size range? Good size range would be maybe like minimum size can be 10 and maximum is 40. So that means our minimum is 10, so we're plus 10, and our max is 40, so we generate random numbers from 30 and we add it. And for our V speed, I want my V speed to only go down, so it should always be positive. And the max that I want it to generate is maybe 4. So next double would generate a number between 0 and 1, I think, and every time I multiply 4, it'll scale it up to a max of 4 and a min of 0. So we go X, Y, size, V speed. I think that should be good. All right, so now that we've generated a whole heap of balls in our game load, we need to update the game update to handle its behavior. So we need to handle the behavior of all the balls in our list. So again, we'll use a for loop. You know what? We can use a for each because we're not going to change it. We're going to go for each ball in balls. We can just go ball.update. Right, so we just update the balls. So each ball will update its own behavior, whatever, you know, however fast it's moving, you know, wherever it's starting. You know what I forgot? I should go balls.load, but not that there's anything in there. Ball.last.load. I'll load the last one that it's added in here. Yep. And finally, do the same thing down here, except instead of updating, we draw. Now watch this. There you go, they're all falling at a different rate. Right. We could now change the behavior of the ball, every ball, by going into our ball, and if every ball reaches the end, so if me y gets if me y gets greater than display size dot height gets to the bottom, then what we could do is we could flip the v speed. The v speed we will multiply the v speed by 1. So we go -1. So we flip it. So we'll make it kind of bounce back up. V speed. Flip it. What's the issue here? Oh yes, because it's from the game window. Alright, so let's try that. So how it goes back up again. Right, it's going back up again. And we could set the V speed back to 0. Oh, yeah, anyway, it doesn't matter. Like, I'm not fussed about how this physics is going to work, but you get the idea there. So I don't like the way this thing doesn't have an outlined. Oh, that's fine. I use a fill. That's why it's got no outline. So in terms of color, you notice that this is our color. Let's have a look at the time. Yes, good time. We could also randomize our color. So we could grab this. So what we'll do is actually we'll put in a public property color. It's probably, yeah, color. Single. Yeah, so we'll do that. Just thinking whether I should just generate the color. No, yeah, it's fine. So we'll have color out there. It's not happy with that now because we've got a name clash. So I have to explicitly say that this is from drawing, from a different library. This is mine. This is from a different library. What I'll do is I'll grab that. And over here, instead of using custom color, I'll use me.color. Whatever the color and this is not a single, this is a color. This is drawing.color. We should give it a default color, just in case we don't set. Oh yeah, no, actually we should now pass color in. Drawing.color. And then over here, give it the color. And now this can use the color that it stored for itself. And then in our game window, we can generate a random color here. So this doesn't work anymore. And over here, we can generate a random color. And over here, we can just generate some random numbers. and then we'll put the color in here. So we need to generate some random numbers here. Alpha is fine. We don't need this actually, but I'll delete that. And this is fine. We just need to generate random numbers for that. So what we'll do is we'll go dim red as integer this time around. Random. So when I'm generating integers, I don't use next double, I just use next, and I can put a min and max. Minimum is 0, maximum is 255. Actually, not 2. I won't go to the ends. Also, I could get a black and a white. Ah, no, it's fine. Yeah, no, yeah, sure. 0 to 55 then, why not? Same thing with red, green, and blue. So you didn't already know the way we're using red RBG in here, red, and colors are determined by the strength of red, green, and blue as you add them together, and then you can make like various colors. So if you want to make blue, you set blue to 255, then red. What's the order here? RGB, green, blue. And then you set red and the other color, green, to 0, and then you make a blue color. Green. Can't spell green. Alright, let's try that. There you go. So you got random balls there, bouncing, kind of going up. It doesn't quite work. It's kind of like bubbles. What we could do is we could make it a little bit more closer to physics. Let's have a look at our time. Oh, we've got enough time. So V speed, we could like we could make it fall faster and faster. We just need to change the V speed. Maybe we'll add a little bit to the V speed every frame to simulate gravity, because gravity speeds things up as it falls down. So we're going to add maybe 0.1. I wonder if that's good. Let's check that. Yeah, so it looks a lot better there. There you go, and that's perfect. That's a really nice simulation of balls bouncing. You can do some damping. What damping is, every time it bounces, it kind of loses a bit of energy. What we could do is instead of reflecting it, make it -1, make it go to the other direction. We make it to go the other direction with less of a strength, so we drop it by 10%. So we go 0.9 instead. So now it's starting to lose its energy, and it's not bouncing as high anymore. Of course, for every ball, we could generate a random value for that, so that all bounce they can all lose energy at a different rate. There you go. And this pretty much concludes the constructor pattern, where, to recap, we created a ball class here. So we created one ball class, and in the constructor here, we allowed ourselves to set different values for the balls, for the different properties, and then the ball will behave in a way that, in whatever you set it, generally the behavior is the same, but its parameters are a bit different. So they fall at different rates, they start at different points, there's slight variations, right? And then in the game window, we used a for loop, generated random values for everything we needed for each ball, slotted into a new ball, and generated and added balls to our ball list. And we did 100 of these. Now I can go to 1,000, but it will just slow down, right? There you go. And then what we did was we use a for each loop, which is slightly different because I already know how many there are. This one, I don't know how many I'm generating, so I need to establish how much I'm generating. So I use a for loop. For each loop it doesn't care how many you got. You don't need to worry about how many you got. You're just going to go through every single ball and update it. So it performs the falling animation. And of course, after you perform the falling animation, you need to draw it. Because if you don't draw it, you won't see the balls. But it is working. The balls are happening in memory. They're all bouncing. Right now they're bouncing in memory, but you can't see it. So you just need to draw it as well. And we need to pass the graphics libraries to this because we're using it here. Thanks for listening, and I'll see you in the next video.